Alright, in this video we'll look at random numbers and complex numbers. Let's start with random numbers. So I've cleared off my screen again. Random numbers. So MATLAB generates random numbers using an algorithm that is almost as good as a truly random number generator. It's going to work for all of our purposes, so we're not worried about the fact that it's not truly random. It's close enough. Here's the easiest way to do it. Use the command rand. So if I run this section, if I say rand2, I'm going to get a 2 by 2 matrix filled with random numbers between 0 and 1. So by default, if all you say is rand, you're going to get numbers between 0 and 1. So it could be anything. It could be, in this case, my format is set to 4 decimal places, so I'm only seeing 4 decimals, but MATLAB is keeping more decimals than that. These are truly any random number between 0 and 1. And it's a uniform distribution, so all the numbers between 0 and 1 are equally likely. Let's create a matrix called A that is rand n5. I want to show you something a little different. Rand n is no longer a uniform random number, but this is going to be a normally distributed random number. Let's look at a 5 by 5 matrix with random numbers here. Let's pull that up. And what you can see is we've got positives and we've got negatives. So if you're familiar with normal distributions, what we're using here is a mean of 0 and a standard deviation of 1. If you're not familiar with normal distributions, think of the bell curve. You know, that nice Gaussian curve that's highest in the middle and then slopes downwards on the sides? That's a normal curve. It means that most of the time we're going to be between -1 and 1. However, sometimes we're going to be beyond -1 and 1. 95% of the time will be between -2 and 2. 99.7% of the time, or something like that, will be between -3 and 3. Here you see we got a very unusual number, something that's farther away from 0 than 3. Cool, I didn't plan that, but we actually got 2 of them. That's pretty unusual. In any case, you'll see we didn't get any negatives that are farther than that. Most of the numbers are closer to 0. And so normal distributions can be very useful because they are so frequently found in nature. But do we have to have a square matrix? Let's see. Rand n 3, 6. So this will be B, and I'll suppress the output on A so we don't have to look at that again. By the way, if I were to run this again, and well, whether I suppress the output or not, it's going to regenerate random numbers if I run this script again. So it's going to save on top of my existing A, unless I comment it out. So if you want to keep this matrix for some reason, you can comment it out instead of suppressing the output. All right, let's run this section and see what we get. My screen's a little small, but you can see columns 1 through 5 here and column 6, each of them having 3 rows. So we have a 3 by 6 instead of a square matrix. All right, so with one input, you get a square matrix. And with rand n normally distributed. And if I have 2 inputs, we get an m by n matrix instead. So instead of a square matrix, we're getting whatever size you want. All right, let's look at some complex numbers. We'll wrap this up. Complex numbers, what are those? Any number that has an imaginary part is a complex number. So this is that square root of a negative thing, or the I, that you're all so fond of. And one way to create a complex number is to say, well, there's a couple different ways, but one way is to use the command complex. We say, okay, this number A, and I'm going to use a lowercase because it is not a matrix. This number A is a complex where the real part is 5 and the imaginary part is 3. And then when I run this section, I get 5 plus 3i. You could also say B equals, just enter the I, 9 plus 2j. Oh, sorry, I. We'll use j in a minute because j is another variable that means imaginary unit. So I and j are both special numbers to MATLAB. Let's say 3j. I and j mean the exact same thing. It's just that one of them is more often used by mathematicians and one of them is more often used by engineers. So MATLAB uses both. Notice that it's reporting it as an I even though I input it as a J, because MATLAB is trying to keep me consistent. So there's a bunch of different ways we can assemble a complex number. We can add and subtract them. Let's suppress all of these before we continue. We can say A plus B, and of course, just like complex arithmetic is supposed to do, this is going to add the real parts and add the imaginary parts independently. So that's nice. Let's do some commands with complex numbers. We can do the real A. Tell me the real part of the number called A. And it's going to report just the real part or just the imaginary part. Let's say imaginary A instead. So if A equals 5 plus 3i, the imaginary part is the 3, not the I. The 3 is the complex coefficient, so or the imaginary coefficient. We can also have the command is real. That's not Israel, it's is real. So we can say the number A, is it a real number? And what that's looking for is the complex part equal, is the imaginary part equal to 0? And it's a logical, see this checkbox over here? That tells me it's a logical variable, which means it's either true or false, and of course 0 means false. Let's do one more interesting thing. We can say, let's create a new, let's store it in C. What we can do is say, tell me the complex conjugate of this complex number. So conj of A. That's going to give me the complex conjugate, which just takes the opposite of the imaginary coefficient. So A was 5 plus 3i. We're going to get 5 minus 3i instead. So 5 minus 3i. And the nice thing about those complex conjugates, of course, was when you multiply them together, you're guaranteed to get a real number and not a complex number. All right, that's it for complex and random numbers. See you next time.